Episode 23, titled OSINT int Code and Artifact Leaks, we're going to focus on one of the most practical and high-impact OSINT topics, accidental artifacts that expose internal details and secrets.
In real organizations, these leaks often happen without malicious intent, and they can quietly create direct access paths that bypass otherwise solid perimeter controls.
Pen Test Plus scenarios like to test whether you can recognize this kind of exposure, understand why it is risky, and handle it ethically without turning a discovery into an incident.
The trick is to treat artifacts as evidence of risk, not as invitations to explore everything they might enable. When you handle this category correctly, you demonstrate professional judgment. You minimize exposure, you communicate clearly, and you guide remediation without spreading sensitive material. By the end of this episode, you should be able to describe where leaks come, what counts as a secret, what outcomes can follow, and how to respond safely when you find one.
Common leak sources tend to be boring in the worst way because they originate from everyday workflows that were never meant to be security critical.
Public repositories are one source where internal code, configuration, or build outputs are accidentally made accessible outside intended audiences. Snippets and shared fragments are another source where small pieces of code or logs are posted for troubleshooting or collaboration and unintentionally include sensitive values. Logs can leak secrets because developers and operators sometimes print values for debugging, and those values can persist in files or services that are later exposed. Backups and archived artifacts can leak because they are often copied and stored broadly, and they may include older secrets that were never rotated or removed even after the active system changed. The exam often frames these sources as publicly accessible artifacts without naming a specific platform, and your job is to recognize that the risk is real even when it is unintentional. These sources matter because they are common, repeatable, and often overlooked, which is why they create reliable exam-style scenarios. To handle these leaks responsibly, you need a clear definition of what counts as a secret, because not all sensitive data is equally dangerous in the same way. Secrets include keys, tokens, passwords, and certificates, because each of these can enable authentication, authorization, encryption, or trust relationships. A key might enable access to a service, or allow signing actions that create trusted artifacts. A token might represent a session or an authorization grant, enabling an actor to act as a user or service. A password is an obvious credential, but the exam often tests whether you treat it as a high-risk object that requires controlled handling and minimum exposure. Certificates matter because they can be used to establish trust or to impersonate systems if private components are exposed. And they can also reveal naming and environment details even when not directly exploitable. The professional mindset is that if the value can be used to authenticate, authorize, or establish trust, it should be treated as a secret and handled under strict discipline. Configuration files are especially revealing because they often contain internal paths, hosts, and environment distinctions that are not meant to be visible externally. A configuration file can reveal where services live, how environments are segmented, and what endpoints or internal names are used across stages like development, staging, and production. It can also reveal the presence of third-party services and integrations, which affects both exposure and boundary constraints. Even when a configuration file does not include direct secrets, it can still provide a map that makes later discovery and enumeration easier for an attacker. On Pen Test Plus questions, configuration leaks are often a bridge between public artifact and internal understanding because they illustrate how attackers can learn about internal structure without ever touching the internal network directly. This is why configuration handling and publication practices are such a consistent source of risk. When you see configuration artifacts in a scenario, treat them as both exposure and intelligence, and handle them with minimum necessary evidence practices.
Build artifacts and packages introduce a different form of exposure, where the leak is not a credential, but a detailed fingerprint of what the system is made of. Dependency lists can reveal what libraries and components are in use, which can influence vulnerability discovery and prioritization. Debug symbols and verbose build outputs can reveal internal function names, error handling behavior, or structural details that make analysis easier for an attacker.
Version strings can reveal exactly what software components are in place, which can turn a generic guess into a targeted hypothesis. In exam terms, these artifacts often show up as publicly accessible package contents or exposed debug information, and the correct response is usually to recognize the increased risk and recommend reducing exposure and improving build hygiene. The key is to understand that even non-secret artifacts can increase attack feasibility by reducing uncertainty. When you treat build artifacts as accelerators of attacker understanding, you can explain why they matter, even when they do not contain a password. Commit history can reveal mistakes and sensitive removals, and this is a subtle but important idea because people often assume that deleting a value removes it from history. If a secret was committed once, it may remain accessible through history, even if the current version appears clean, and that persistence can prolong risk. Commit history can also reveal patterns of rushed change, which can indicate process weaknesses and increase confidence that similar mistakes may exist elsewhere. In some cases, commit messages or diffs can expose internal paths, system names, or troubleshooting details that were not intended to be public. The exam's conceptual point is that exposure is not always about what exists now, but about what existed and can still be accessed through artifact history. This is why remediation often includes not only removing exposed values, but also rotating them, because you cannot assume the value was never copied. When you see scenarios involving removed secrets or older commits, treat them as still risky until rotation and verification occur.
The outcomes of secret and artifact leaks can be severe because they can enable account takeover, data exposure, and lateral access without the usual barriers. Account takeover can occur when a leaked credential or token grants access to a user or service identity, bypassing normal authentication friction. Data exposure can follow when that access reaches storage or records, especially in systems where identity permissions are broad or poorly governed. Lateral access can occur when a leaked secret is tied to a service account that has reach into internal systems or trusted relationships, allowing expansion beyond the initial exposure. Even when a leaked artifact is not directly exploitable, it can reduce attacker effort by revealing internal structure, dependencies, and likely entry points, increasing likelihood in practical terms. Pentest Plus questions often want you to connect the leak to realistic consequences, not just to label it as bad. When you can articulate outcomes clearly, you can also prioritize the right immediate actions and recommendations.
Ethical handling is non-negotiable in this area because secrets are powerful and easy to misuse, even unintentionally. The professional rule is to not reuse secrets beyond authorized validation, meaning you only do what is necessary to confirm the risk within scope and rules of engagement. You should not share secrets broadly, and you should avoid storing them in insecure places because mishandling discovered secrets can create new exposure. Ethical handling also means minimizing how much of the secret you copy into notes or reports, because the act of reporting can become another leak if the report is distributed widely. If the scenario implies that a secret may enable access, the safe approach is to treat it as toxic material, handle it carefully, validate minimally, and escalate promptly. On the exam, answer choices that involve use the key to explore everything are often wrong because they ignore ethical boundaries and minimum necessary principles. The correct mindset is to prove the point and then reduce risk, not to maximize access.
Reporting discovered secrets requires a specific style, minimal exposure, clear steps, and rapid risk reduction guidance.
Minimal exposure means you avoid including full secret values in reports and communications, using careful redaction or partial representation so the team can identify the affected secret without the report becoming a credential store.
Clear steps means you specify what needs to happen to remove the exposure, rotate the secret, and confirm that access paths are closed, without forcing the team to guess what fix-it means.
Rapid risk reduction means prioritizing actions that reduce likelihood quickly, such as revoking or rotating credentials, removing public artifact access, and tightening permissions that make a leaked secret high impact.
The report should also explain the scope of exposure in plain terms, such as where the secret was found and what it could likely access, without encouraging misuse.
In exam reasoning, the best answer is often the one that combines responsible reporting with immediate containment steps, rather than the one that focuses only on documenting the discovery.
When reporting is clear and careful, remediation becomes faster and safer. Now, walk a scenario where you find an exposed key and choose safe actions, because this is where professionalism is tested.
Imagine you discover a publicly accessible artifact that appears to contain a key-like value, and the prompt indicates you are authorized to assess the organization's exposure and report responsibly.
The first safe action is to treat the value as sensitive and to minimize handling, meaning you avoid copying it unnecessarily and you avoid sharing it casually. The next safe action is to confirm the exposure exists in a minimal way, such as verifying that the artifact is accessible and that the value appears to be a real secret type, without using it to access unrelated systems. Then you document the discovery in a controlled way and notify through the agreed escalation path, because the organization may need to rotate and revoke quickly. Finally, you await direction for any further validation that might involve using the secret, because that decision should align with rules of engagement, scope, and risk tolerance. The exam typically rewards this restraint and escalation pattern because it reduces harm and preserves defensibility.
Quick wins in remediation for this category tend to follow a clear pattern: rotate secrets, remove exposure, and add controls that prevent recurrence.
Rotating secrets is often the most urgent step because you cannot assume a leaked secret was never copied, and rotation reduces the window of misuse. Removing exposure means ensuring that the artifact is no longer publicly accessible and that future builds or repositories do not include the sensitive material. Adding scanning controls means implementing checks that detect secrets in code and artifacts before they are published, reducing the chance that the same mistake happens again. These quick wins also align with root cause thinking, because rotating fixes the immediate risk while scanning and process controls reduce recurrence. On Pentest Plus questions, the best recommendation often includes both immediate containment and preventative controls, because that demonstrates maturity. When you can state quick wins clearly, you help the client act quickly without creating additional exposure.
Common pitfalls in this area include assuming a key works and sharing it insecurely, and both are surprisingly easy mistakes. Assuming a key works can lead to overclaiming impact because the key may be expired, restricted, or unrelated to production, and the exam expects you to avoid certainty without validation. Sharing it insecurely is worse because it creates new exposure, turning an internal remediation effort into a broader incident. Another pitfall is exploring widely with the secret to see what you can reach, which can violate scope and increase harm, even if the intent is to prove impact. There is also a pitfall of treating the discovery as purely technical and delaying notification, which can increase risk if the secret is active and exposed publicly. Pentest Plus often tests whether you understand that the safest and most professional move is fast containment and careful communication, not extended exploration. When you avoid these pitfalls, you demonstrate that you can handle high-risk discoveries responsibly. A simple memory phrase can keep your response disciplined, and a good one is find, minimize, notify, rotate, verify. Find means identify the exposed artifact and recognize that it contains secret-like material or sensitive internal detail. Minimize means reduce handling and avoid copying or spreading sensitive values beyond what is necessary to prove the exposure. Notify means use the approved escalation path so decision makers can act quickly and coordinate containment and remediation. Rotate means revoke and replace secrets and related access paths to reduce the likelihood of misuse, treating exposure as potentially compromised. Verify means confirm that the exposure is removed and that the rotated secrets and tightened controls have actually closed the risk safely. This phrase is short enough to remember under pressure, and it aligns with both ethical discipline and effective remediation. If you can repeat it, you can respond consistently even when the discovery is stressful.
In this episode, the core logic is that accidental code and artifact leaks expose internal detail and secrets in ways that can enable account takeover, data exposure, and lateral access, often with very little attacker effort. Common sources include public repositories, snippets, logs, backups, configuration files, build artifacts, and commit history, and each can reveal different kinds of risk. Secrets must be defined broadly as anything that enables authentication, authorization, or trust, and they require ethical handling with minimum necessary validation. Reporting should minimize exposure, provide clear containment and remediation steps, and prioritize rotation and removal over extended exploration. Avoid pitfalls like assuming a key works or sharing it insecurely, and use the find, minimize, notify, rotate, verify phrase to keep your response disciplined. Now rehearse the safe handling steps once by imagining you discovered a secret in an artifact and then walking yourself through minimizing handling, notifying properly, and verifying remediation, because that rehearsal is how you build calm judgment under pressure. When you can do that, you answer exam scenarios with the same professionalism that real clients expect.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.